Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture I am trying to discuss about the implementation of implementation using Python for the frozen lake environment. How we build a random agent for a frozen lake environment using Python, that we will discuss now. So as usual, what is the first stage? So first we have to create the frozen lake environment. So how we create the frozen lake environment? In the frozen lake environment containing 4x4 grid, it is represented as a 4x4 grid. This is the starting state, goal state, H, this is the H and this is H. So these H will represent the holes, and whereas these all F's are represented the frozen surfaces. So it is the 4x4 grid, start to frozen, hole and goal state. 4 actions are there, up, down, left and right, we discussed last lecture. And reward is, if you reach the goal, you got the reward of 1, otherwise it is a 0. Okay. And coming to the states, every cell in the grid represents one state. The starting cell represents the with a state 0, and goal cell represents the with state 15, and this whole cell represents the state 7, and this whole cell represents the state 9. Okay. So coming to here, now I want to create an environment. So import gymnasium as gym, and we have to create an environment. How we create the environment? That is env equal to gym.make. You have to call the frozen lake environment, FROZEN, frozen lake, lake v1. Okay. So then you can simply print frozen lake environment created. Frozen lake environment is created successfully, like that. Now run this one. So yes, frozen lake environment is created, that's fine. Now, so I want to see the state information. First reset the environment. So reset the environment. So how we reset the environment? You can call this environment env.reset. It will help to reset the environment. It will provide some additional information and also states values. Okay. So you can see how. So maybe I can keep it as a state comma info equal to env.reset. Reset the environment. Then if you want, you can print the state. What is the state? After resetting the whole environment, now we have to print on which state and which position currently robot is there. Okay, now see. So the state equal to 0. That means it is at the starting position. And again, if you reset once again 0. So whenever we are resetting, that means your game will start from the 0 point, starting point. Whenever you are resetting the environment, wherever the position of your robot is, it will again starting from this point only. So that's why every time state equal to 0. Every time state equal to 0 when you are resetting the environment. Okay. Now coming to the action space. So how we got the action space information? So action equal to env environment. Which environment? This is the frozen lake environment we imported already, we created already, and action space. And you can print action, what it will be, you can observe. So it is a discrete of 4 values. What are the discrete of 4 values? It is a 0, 1, 2 and 3. So 0 represents the move left, 1 represents the move down, 2 represents the move right, 3 represents the move up. So these are the various actions. That's why you are seeing discrete 4. That means there are the 4 actions. Okay. Now I hope you understand. So it is the 4 actions are there, and how we get that information? So this is the code we have to use to observe the action space. So now we have to generate the random action. That means the robot or a child chooses some random action from the available actions. What are the available actions? 0 represents the left, 1 represents the down, 2 represents the right, 3 represents the up. Okay, so which action the robot will choose randomly, that we have to provide. That for that purpose we have to provide the code, write the code. So random action. Okay, so action equal to env dot action space dot sample. So sample, that means some random action generated. If the action is equal to 0, then so you can print what it is, move left, move left. Okay, action 0. So if it is action 1, if the action value is 1, so the action value is 1, then it is a move down. If the action value is 2, then it is move right. If the action value is 3, then move up. So these are the 4 actions, right? Now you can see how which action is randomly generated. So randomly move right, that means the robot want to move right side. If you rerun again, move up. Now the agent or robot wants to move up. So if you run again, now it is a move down. So random action will be chosen by the agent or robot or child in the FrozenLake environment. Now, once the random action is chosen by the agent, by the car, then environment will apply that action onto the agent. So once that environment applies that action onto the agent, then the agent position will be changed, agent state will be changed, and agent will got some reward. If the agent is there and he choose some action and environment applied that action either up to right to left to or down, he choose that action. So based on that action, the robot will move from the one state to the another state. So what is the next state? That information we have to provide, and also when it reaches to the next state, he will got some reward. For suppose the next state is a goal state, he got a +1. Otherwise, he got a 0. That information also we have to provide. And also we have to know whether the terminated or not. Terminated means your game ends. So whether maybe reaches the goal or you may falls into the hole. Or it may be truncated. Maybe you reaches the maximum number of steps or maximum number of episodes. So then also it is a truncated. So what is the state of the algorithm that we have to discuss now? So we discuss here move down. Sorry. Now I want to agent act. Agent act means in the previous cell, the agent randomly chosen the action. Now he act based on the chosen action. If he choose right direction, so he will move right. If he choose left direction, he will move left. If he choose up direction, he will move up. If he choose down direction, he will move down. So that act, that should be act. So that act we have to implement now. So how we implement that act now? So once again I will write this code. Okay, and same thing I will call again. Now, so some random action is chosen. Now we have to apply this action. So now tell me what is the current state. First of all, we have to note down the current state. So current state equal to your starting state only that we got here. Current state is nothing but this is my current state. Okay, this is my current state. Done. Okay. Now coming to now I want to apply this action, this random action on the agent. Okay, agent act as per the random action. Then what happened? env dot step. You have to choose that random action. Now it will give the values like next state, and it will give the information like reward, and also it will provide the information like terminated, and also it will give the information about the truncated or if any additional information. Now you can visualize everything. So I want to print f current state equal to this current state. Similarly, otherwise I will copy. So next state. Next state, once this action is applied, what is the next state? Next we will observe what is the reward it is getting. What is the reward it is getting based on the current action, and whether the algorithm is terminated or not, or truncated or not. Done. Now you can see. So this is the move left. Action chosen is move left. What is the current state? 0 only. Current state is 0. It is the current state 0. Now once the robot or agent or car, whatever it may be, it moves left, then in the left side no state is there, only like a wall. So then what happened? It can't move left side. So it will stay in the same state only. If the agent took the left action, there is no state toward the left side. It tried to move left, but because of this wall, it will be stay here only. There is no state here. There is no other state toward the left side. So when the car take the left direction, when car trying to move toward the left direction, because there is no state toward the left side, so it will stay in the same state only. That's why after applying this move left action, current state is 0, next state also 0, because state will not change, because on the left side there is no state. So whatever the current state, it will be the next state itself. Now reward, once it reaches to the goal, then only reward equal to 1, otherwise reward equal to 0. So still it is in the 0 state only. So that means it is not a goal state. So reward equal to 0. So the algorithm is not terminated, not truncated. So this is how we can apply the given action onto the agent, and based on that one, how the state and reward is updated. So that we discussed here. Now I will build the random agent. So now I will build the random agent, means maybe I set some 10 or 20 episodes. So what happened? Episode 1. So episode 1 means it is the starting. So your agent will start from the starting position, and it randomly choose the action, act the action, and the state will be updated, and this process will be repeated for the 10 episodes or 20 episodes. When this algorithm will be terminated, if it reaches to the goal, or if it reaches the whole, or the time limit is reached. So goal of the random agent is survive and reach the goal by chance. Here we are not applying any algorithm, just it is a random chosen. Okay, as of now we are not applying any reinforcement learning algorithm. Just we are randomly actually chosen, that's it. Agent will choose the action randomly. So based on these random actions, we will check whether it will reach the goal or not within the given episodes. Okay. So goal of the random agent is survive and reach the goal by chance. Why is that by chance? Because these are random actions he is chosen. So based on these random actions, whether he will reach the goal or not, we are checking. Random agent is not optimal, but useful to understand the environment. It's not optimal, it is a useful to understand the whole environment, how it will work. So what I want to do is, I want to build the random agent. How? As usual, import gymnasium as gym. Okay, and create environment env equal to gym dot make frozen lake v1, frozen lake v1, and so environment is created. So once environment is created, first reset the environment. Then reset the environment. So reset the environment means maybe you can write current state comma some info, additional info if any. So env dot reset. So it will give the current state information. You can print it. So print current state current state. So print the current state. So what next? Now we have to run this algorithm for the, now currently the robot at a particular position. It may be a 0 mostly. Now we have to start the iterative algorithm, and in the iterative algorithm, in iterative process, first episode agent will choose some random action, and he will act as per the random action. He will go to the next stage, and based on the which state he reached, based on that one we will assign the environment will give the reward. Okay, so if he falls in hole or if he reaches the goal, then algorithm will stops. Otherwise, this process will be repeated until number of episodes we mentioned. So we will see now. So first total reward I want to calculate. So total reward equal to 0 over 10 episodes. I want to use total 10 episodes. I want to give the chance to the agent explore for the 10 episodes randomly in a frozen lake environment, and I want to check whether it reaches the goal or not randomly. So number of episodes I consider as a 10. Now for episode in range of episodes. Now what we have to do here? Random action. So action equal to env dot action underscore space dot sample. So some random sample action chosen, and act means, so you have to apply the generated action or randomly chosen action on the environment, by the environment on the given agent. Okay, then what it will give? It will give the information about the once this action is applied on the given robot, then what it will provide the information about the what is the next state, what is the reward, what is the terminated, truncated information that we have to call. So I already used that one. I want to use directly here. This is what I want to use directly. Done. Now I want to print all this information, like print format string next state equal to, and current state, what is the current state, what is the next state, equal to, and reward that's equal to reward, and what I want to print, terminated and truncated information. Okay, terminated and truncated information. So there is a terminated and a truncated information. And also I want to see the episodes also. Episode equal to current episode plus 1, why plus 1? Because the episode equal to 0, that means it is the first episode. If the episode equal to 1 means it is the second episode. And yeah, the next state. Done. So now what we have to do? Now update the total reward, calculate the total reward. Okay, so total reward is equal to total reward plus the reward value. So if the next state becomes goal state, then reward become 1. Otherwise, reward is always 0. And that's fine. Now termination. If terminated, that means if it is a reaches to the hole or reaches to the goal. Terminated or truncated, if reaches the maximum number of epochs, truncated, then you can break it, and done. So once it is completed, now you can calculate the average reward also. So average reward equal to average reward equal to total reward divided by number of episodes it was executed plus 1. Why plus 1? I said already. The episode equal to 0 means it is the first episode. Episode is 1 means 2 episodes. Episode equal to 2 means 3 episodes. That's why I'm getting. Now you can print. So print total reward equal to total reward and average reward equal to average reward. That's it. This is how we can build the random agent. Okay. Now run this one. I want to give 10 episodes back. Yeah, you can see current state is 0 when episode 1. And I forget to mention the action also. It's better to mention the action also. So we will include one thing. We will include action space also. Action also. What action, random action chosen. That also we will discuss. So action equal to action. So action equal to 0 means it is a left. Action equal to 1 means down. Action equal to 2 means right. Action equal to 3 means up. Okay. Now we can see. Yeah. So you can see current state is 0. Okay. So episode 1 is the first episode and the action equal to 1. Action equal to 1 means action equal to 1. Action equal to 1 means we'll have the information, right? Action equal to 1. Here mentioned actions. These actions somewhere I have mentioned. Yeah. Action equal to 1 means move down. So when the agent moves down, then what is the state? When the agent moves down, what is the state? When the agent moves down, if the starting point is 0. So starting point is 0. This is the 0 and moves down means it comes here. That means 0, 1, 2, 3, 4. So next state becomes a 4. So next state becomes a 4. Current state equal to 0 and reward equal to 0. And one more thing I forgot. We have to update the current state, right? See, for first episode, it is moving from here to here. For the second episode, this episode becomes a current state. And from this position, what is the next state we have to find? So that is missing here. I will write here. Current state equal to next state for the next episode. It will become a next state. Current state, next state will become a current state for the next episode. Okay, now you can run. Yeah, that's how it is working now. Okay, and so action 0, you can see current state is 0. 0 means, so this is the 0th state. Now, what action chosen? Action 0. Action 0 means left. So when from this position it try to move left, there is no state left side. So it stays in the 0th state only. So next state also 0. So current state 0, next state 0. So this is not your goal. So that's why reward equal to 0, not terminated, not truncated. That's it. So but you can see I gave the number of episodes equal to 10, but it is executed only for the 4 episodes. Why? You can see here terminated equal to true. Terminated true means algorithm is terminated. When the algorithm will be terminated, whether it reaches the goal or it falls in the hole. Then, but reward equal to 0. Reward equal to 0 means it falls in the hole. If they reaches the goal, then reward becomes a 1. But reward equal to 0 means it reaches the hole, so that algorithm is terminated. Okay. So that's how we can implement the frozen lake environment. We can implement the frozen lake environment. Now it take the 6. So still not reaches the goal, but terminated. Why? It reaches to the reward 0. Reward 0 means it reaches to the hole. So hope you understand how we build a random agent in a what's called frozen lake, a random agent in a frozen lake environment. You can increase the episodes also. If I take 100 episodes, but it is terminated at 14 because it falls in the hole. It's not reaches to the goal. If you reach the goal, then reward becomes 1. Reward equal to 0 means it not reaches the goal. If not reaches to the goal, then why it is terminated? Because you can see the options here. It will be terminated if it reaches to the either hole or goal. If reaches to the goal, reward equal to 1. But reward equal to 0 means it reaches to the hole. That's why the algorithm is terminated. So I hope you understand this implementation. And in the next lecture, we will come up with some other new environment. Until then, bye. Thank you.